Now we will discuss Theorem 1015. If two chords intersect in the interior of a circle, so for example, let's draw a circle, and let's draw a chord CD, such as that, and another chord AB, such as that, and let's say they intersect in point E. So if two chords intersect in the interior of a circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segment of the other chord. So the product of the lengths of segment CD would be, therefore, CE times ED, and that would equal the product of the lengths of chord AB, which would be AE times EB. So in other words, when the chords intersect, that point of intersection creates, it sort of cuts each of the chords in pieces, and the two pieces of each of the chord, when multiplied together, for each of the chords are equal. Okay, so how do we prove this theorem? Actually, the proof is relatively easy. We need to draw an additional two chords, chord AC and chord BD. When we do this, we actually are creating two similar triangles. The way to see that is that notice that we have an inscribed angle ACD, and that intercepts the arc AD, and we also have a inscribed angle ABD that intercepts the same arc. So we know from a previous theorem that inscribed angles that intercept the same arc are themselves equal. So this angle is equal to this angle. Now, in a similar way, angle CAB and angle CDB are inscribed angles, both of which intercept arc CB. So these two angles are equal as well. And, of course, the vertical angle is equal. We can make sort of an equality there. So we have two similar triangles, and what we know about similar triangles is that the ratios of their sides are equal. So we can create a ratio between this angle and this angle is going to be this side similar to this angle and this angle, so we know that the ratio of CE to EB is going to equal the ratio of AE to is going to equal to AE to ED, because that's the side between the two notched and the three notched angles. We have to make sure we have our sides correct. So that would be equal to the ratio of AE to ED. And now if we cross multiply this equation, CE times ED is equal to AE times EB. Well, that was exactly what we needed to prove. Here we have CE times ED, CE times ED equals AE times EB equals AE times EB. And that's how easy it is to prove Theorem 10.15.